Hi everyone, welcome back. In this video of MLOps Zoomcamp, we will train a model for predicting the duration of a ride. This video is optional, so you do not have to watch the video. You can just look at the result at the end, maybe check our GitHub with a notebook, and that would be sufficient. But if you want to see how we built a model from the very beginning, you can stay with me now and watch how I do this. So we are using the same notebook that I created previously in the previous videos. And in the previous video, I showed how to set up the environment. So in this video, I want to use that notebook that we created previously and train a model. So I will hide the toolbar and the header, so I have more space actually for coding. So when you look, when you see my Jupyter, now you know why it looks so weird. And now we will use this data. And actually there is data from 2022. We will not use this. We will just use data from 2021. So I will use green taxi data. I'll copy the link. Now we will download this. So I will go to the instance. I'll create a folder here. I'll call it data. And I will download the data from January, and also I will download, I will download the data for February. Okay, so we have the data, and now let me just read the data with pandas. By the way, I assume you already know pandas and you already know machine learning to some extent. If you do not, I recommend you check. I recommend you to check our machine learning Zoomcamp. So this will be ML. So this is the link. This link is actually included here in our MLOps Zoomcamp at the end. So this one. So here from this course, you will find useful this intro. So in the intro, we talk about pandas here in intro. So this is an introduction to pandas. And then other useful thing would be this classification model where we see how to use scikit-learn for building a classification model. So in this particular case, we built a regression model, but still it's pretty similar. So if you do not know these things, refer to the previous course. So here I assume that you're already familiar with all that. So let me load the data. So I'll call it just df data frame. And we have quite a bunch of rows here. So we see that there is vendor ID, pickup date time, drop-off date time. So this is when the passengers were picked up and dropped off. Then a bunch of other things. Other interesting thing for us is pickup location ID and drop-off location ID. So this is the ID of the location when they were picked up and dropped off. Trip distance, also interesting for us. So usually I assume we would actually know the distance of a trip. So let's say when we want to build a model for predicting the duration, we know where the passenger starts, where the pickup location is, where the drop-off location is, so we can compute, we can calculate the distance. So this actually would be one of the features, one of the pieces of information that we will have at our disposal when we will predict the duration. So the rest, like fees, is not really interesting for us right now. It can be interesting for other type of models or analytics. Not here. And if you want, you can read more about this about these columns here in Green Trips Data Dictionary. So it says what kind of information is there. Yeah, so one interesting one could be trip type. So trip type is, we have two of them, street hail. I think this is when a person just waves their hand and then a taxi drives to them, and then dispatch is probably when they call the taxi service or use an app. I don't know. So yeah, I think we can just, for our purpose, we don't need to use all the data set. We can just, I don't think it matters, but we can just go with dispatch here. So I will do some filtering. So this is trip type. Yeah, trip type. And we need trip type 2, right? So this is how we filter it. So and then even before that, I think we are interested in predicting the duration, right? So even before filtering, can be after, doesn't matter. So we need to calculate the duration. And for calculating the duration, we need to subtract drop-off location ID from pickup. From drop-off date time, we need to subtract pickup date time. And if we try to do this, we see that there is unsupported operand type, string and string. And the reason for that is the date is not parsed by pandas properly. So it is string, and we need to tell pandas that it's actually not a string, it is a date time. So for that, let me just re-execute this one more time. And I will use a special function from pandas called toDateTime. And this function will parse the string that we have in this series, in this column. And it will create datetime columns. And yeah, so this will be drop off, and this will be pickup. Right, so now we will do parsing, and now, oops, we can actually execute this operation. You see, this is the result. So it says that for this trip, the duration was 3 minutes 56 seconds, and so on. So I will just create a column that I'll call duration, and then we can do, let me see. Yeah, before we do filtering. So here it's not something we can just take and use as a target variable that we can just immediately put to our machine learning model. I think the target variable we can use here is duration in minutes. And to actually convert this thing to duration in minutes, let me just first take the first value here. So this is time delta. I'll call it TD. And in time delta, we have, I think, duration in minutes, something like this. Let me find it. Seconds, right? Total seconds. So total seconds says how many seconds this time delta is in total, meaning duration in seconds. So seconds is probably too granular for us. Let's go with minutes. So then for the first one, it was 3 minutes, almost 3 minutes. And we just need to apply the same thing to every element of the duration column. And we will use apply function in pandas. Apply. Yeah, so we'll use lambda. But lambda, this is just the usual function that will be applied to every row, every element of this duration column. And yeah, we will do that. So we will apply this function, and we will write the results back to the duration column. Okay, I'll put them here. And now when we look at the duration column, we see that this is in minutes. Right. And I think we can look at the distribution of how exactly durations look like. And I think I'll do some filtering before, right? So first I will do filtering. So now we have a bunch, like we have fever rows. And now I want to look at the distribution of this duration. So for that, I'll do imports here at the beginning. So I'll use a library called Seaborn. This is a library for visualization, and I'll use a library called matplotlib. And I can just visualize the distribution using this distplot duration. Yeah, we see that it has a very, very, very long tail. And yeah, I don't know why they decided to deprecate it. This is such a convenient function. Anyways, so it's not really possible to see what's happening because of this long tail. So let's do describe. So it is a function from pandas, a method from pandas that describes, gives us information about the values here. And we see that, yeah, indeed the maximum value is very long. I think it's like almost a day. That is a very long trip. And we also have trips that are super short. There are trips that take less than 1 minute. I don't know what kind of trips are those trips. So, which means that we probably need to do some filtering. So let's look at percentiles. So I'm interested in looking at 95 percentile, 98, and 99. So we see that most of the data is within 1 hour. And I think from the business point of view, it makes sense to focus on this duration, so on predicting duration that is less than 1 hour. So we can just add some extra filtering. So for example, we can only focus on duration that is at least 1 minute, for example, and duration that let's say 60 minutes or less. So I'm wondering how many of such records are there. So it's actually only 50% that fall in this. I'm wondering why. Okay, this looks strange. Probably a lot of them are less than 1 minute. So let's see. Yeah, a lot of them are less than 1 minute. Maybe this something is wrong. I don't know why would somebody hire a taxi just to travel a little bit. Maybe we shouldn't have selected this trip types too. So let me quickly check what happens if we don't do filtering. Yeah, probably something is weird here. Okay, so let me just keep those. So it's actually, this data set is a lot larger. I don't think we need that much data, and we have also a lot of nonce, right? Anyways, let me take a subset of this that have this duration. And actually all this information that is missing here, it's not important for us right now, as long as we have this information about pickup datetime and drop-off datetime. So let's just use that. Okay, so the next thing we can do is we can think what kind of categorical variables we will use and what kind of numerical variables we will use. So I don't think, maybe vendor. So when there are two vendors, and there are also cases when the vendor is unknown. So maybe we can use vendor as a categorical variable. Maybe one vendor has faster cars. Yeah, let's not use it right now. So right now we can just focus on pickup location ID and drop-off location ID. And then for numerical, we can use Passenger count probably doesn't make much sense. I don't think. Yeah, maybe if there are more passengers, the cars are slower. But let's say for the first iteration of the model, we will just go with trip distance. Right. And then, of course, we can add more features, like, for example, from this pickup date time, we can infer a lot of, we can extract a lot of useful information. For example, um, like what is the time of the day, if it's weekend or not weekend, if it's a public holiday, that will influence how long it takes. For example, if it's a working day during rush hours, then of course it will take longer. But for now, we will just have these simple features: pickup location ID, drop-off location ID, and trip distance. And yeah, let's train a model, right? To train a model, we need to do something with these categorical variables. And actually, for categorical variables, right now, if we look at D types, they are integers. So in machine learning Zoomcamp, I showed you how to actually do one-hot encoding. So I think one of the yeah, this one. So one of the videos there was about one-hot encoding. So if you don't know what it is, check it out. For implementing one-hot encoding, we can use, for example, dictionary vectorizer. And dictionary vectorizer treats everything that is not a number as a categorical variable. But here, since it is a number, it will assume that it is a numerical variable and will not try to do one-hot encoding for this. So we actually need to turn it into a string. And we can do it like that. So now if we look at D types, now they are objects, which in pandas means strings. I think if I do this now, it will complain. No, it works. I thought it would complain because we did this thing here. Doesn't matter. It seems it works. So now let me check D types quickly here. Yeah, so they are objects, so all good. And we need to import dictionary vectorizer. So I will import it right now. It's from scikit-learn. It's feature extraction, import dictionary vectorizer. And dictionary vectorizer, we'll just use it as is. And actually, as the name suggests, it vectorizes a dictionary. It turns a dictionary into a vector. But we need to have dictionaries. So right now we do not have dictionaries. We have only we have a data frame. So we need to turn our data frame with the features we want to use, categorical and numerical. We want to turn this data frame into a bunch of dictionaries. So I'll quickly show you how it looks like at the end. So take the first 10 only, and then for them we can do something like to dict orient records, and then each of the rows is turned into a dictionary. So we can apply to the entire data frame. So I'll call it train dictionaries. And then this is something we can feed in, we can put inside our dictionary vectorizer. So dictionary vectorizer, feed transform, we put it and we get our feature matrix. So this is the matrix that we will use to train our model. And we can see the feature names that this vectorizer uses. So this is our one-hot encoding. So for each location, we have a feature, pickup location and drop-off location, and then trip distance is a numerical feature. Its dictionary vectorizer does not attempt to do any post-processing or any pre-processing with this feature. Okay, now we also need our target. So our target is, I think, distance, right? And so let's get it. Data frame target. What? Duration, sorry. No, it's values. So this, let me call it y train. And yeah, this is our target variable. This is our feature matrix. So we have both. We have our X, we have our Y, and we can train a model. So we train a logistic regression model. So let me add it here from scikit-learn with linear models, import logistic regression. So I'll call it LR, short for actually we need linear regression, of course, because this is a regression model. This is not a classification model. So I'll call it, it's still LR, linear regression. I will not specify any parameters. I'll just do fit and then X train, Y train. So this is our model that we just fit. So we have the model, and now we can apply this model. We do not have validation data set here. We will load this later. We will use February as the validation data set. But I just want to apply this model to train data set and see what actually happens. So I'll do LR predict on the same training data. So it will be our Y prediction. And now I want to visualize it. I'll do SNS dist plot, and I'll visualize first predictions. So label will be prediction, and then I will visualize the actual value. Train, this will be actual. Then I also need to plot the legend. And yeah, we see that the prediction and the actual values look pretty different for some reasons. So yeah. And yeah, let's see actually. Yeah, I don't expect this model to be particularly good, but let's see how well it does when we try to estimate the score. So for estimating the score, for calculating the performance of this model on the training data set, I will use root mean squared error from scikit-learn, import metrics. From metrics, we'll import mean squared error. So we'll use this for evaluating the performance of our model. So first it will be Y true, then Y prediction, and we will say squared false. So we want to compute root mean squared error, and the root mean squared error is 9 minutes. So our model is wrong on average by 9 minutes, which is not ideal, right? So if you want to reach somewhere within 30 minutes and you're in a hurry, but it turns out that it takes 40 minutes, then yeah, it's not great. But it's better than nothing, right? So let's say this is our baseline. I'm wondering what happens if we, let's say, our categorical, we don't use categorical features at all. So we'll do that. Yeah, of course, it's just one feature. Yeah. It doesn't look very good. I don't know what is here. Let me just look at predictions alone. Yeah, it doesn't look very good. It probably predicts like 16 minutes for pretty much everything. Yeah, not a great model, I guess. And for this model, the error is 12 minutes. If you think about this, then the difference between 12 and 8 is not that large. So we can just predict everything that you'll reach your destination within 16 minutes, and that is already a good model. That's interesting. Okay, so let me put back these variables, and I will retrain the model. Yeah, so we have this model which, yeah, could be better. And I think we can now try to improve this model. Of course, we can try to see what kind of features we can add, but let me try to do a different model. So we use a visual linear regression. I want to try using Lasso regression. So let me import this. So Lasso. So this is like just a kind of type of linear regression with regularization. And I just need to take this thing, then prediction. And yeah, I just realized that I'm actually still doing this on train. So maybe before I try to do Lasso, let me go back a little bit and first check how well it is doing on the validation dataset, because that was training. That was training. So probably on validation, it's doing even worse. And yeah, so we will come back to this a bit later. And now I want to put all the things we did here inside a simple function. So we don't want to execute this well, first for training dataset, then for validation dataset, then maybe for training dataset. So this is just too much copy pasting. We want to have a function, a convenient function that we can use, that we can just take and execute. So I will put first everything together. And yeah, this one perhaps as well. And I think this is all the pre-processing we need to do right now, like pre-processing when it comes to reading the data frame. So we do some filtering here. Yeah, and then there is some pre-processing that we need actually to turn this into a feature matrix. That is a separate thing. And now let me add this, let me put this inside a function. So I'll call it read data frame. So there will be file name. So yeah, so here instead of that, and we will return data frame. So here we don't need numerical actually, because we don't do any pre-processing for this. We only do pre-processing for categorical here. Yeah. And let's now load train and validation. So for validation, we'll use February. Okay, so we have both data sets. Let's see how large they are. Okay, so we have 73,074, almost 74,000 for train, 61 for validation. Okay, now let's do this thing that we did here. So this is another part of our, let's call it training pipeline, that we actually do all that. And yeah, so this is training the model part. This is predicting, the predicting part. And this is the evaluation part. So I'll remove that. And now I will copy this thing and put it here. So here we create dictionary vectorizer. So this is our training dictionaries. For then, yeah, it's just I'm doing a little bit of cleaning because I want to do now the same thing for validation. So here it will be validation dictionaries, and then yeah, here it's actually train. Where do we keep the, yeah, let me put it here. So this is our categorical numerical variables that we use here. Maybe I should even keep them in the same cell. So in case I want to experiment and maybe add another categorical variable, I can just do this with without executing too many cells. Okay, so for validation dictionaries, we do the same thing. That should be validation. And then X validation should be, instead of fit transform, we just do transform. Validation index. Okay, and now we train our model, and then we predict the model for X validation, and we compute the mean squared error for Y validation. Actually, yeah, so this is something we need to do here. So we have Y train, we also need to have Y validation. So validation. Okay, we have our Y's, and now let me execute this. Okay, it's 10. So it got a bit worse because that one was a training data, and probably the data changed a little bit. So that's why it's a bit worse. So now we have this as a baseline. Now let's try our Lasso model. Right? So everything else remains unchanged. I just replace linear regression with Lasso and try to train a model. And I see with the default parameters, it is worse. So we can try to change the version of the value of alpha. So if this is very small, I see that it takes some time to train the model, and the result is not much better. So let's try a bit bigger value. Yeah, also not better. Maybe this. Yeah, actually it doesn't seem like it helps, which is very strange because when I was doing this before recording the video, Lasso was better. Yeah, okay, I guess it just means that, of course, we can improve this more, but I guess, yeah, just means that linear regression is better. We can also try another model. So let me try rich regression. So which is like Lasso, also regularized linear regression. Rich. I think rich is faster, but is it also alpha? I don't think it changes anything when I execute this. It's just always the same thing, right? Well, at least it's fast. Okay, so rich is not better as well. Okay, so maybe we can do something else. Maybe instead of just using this pick application and drop off location, we can do something smarter. For example, we can combine them. So right now we use them separately as different features, but we can come up with another feature which we'll call, for example, pick up drop off pair, right? And this will be nothing else but a combination of this pick up location ID plus drop off location ID. So I'll do this for both train and validation. So this is how it actually looks like. If we look at the end, you see this is just, we have a pair, which makes more sense. Like if we just look, if we just take this as an average, or just take this feature as is, it means, okay, what is the average duration rate for everyone who is coming from this pickup location, and the same one for this drop-off location. Yeah, maybe it doesn't make much sense to use them separately. And here we add what so-called interaction features. So right now we will include this feature, but we will exclude other features. Let me re-execute this. We don't need to execute this one, and yeah, you see it actually became much better. Reach is still quite bad. I'm wondering why. So maybe we need to add a smaller alpha, or actually bigger alpha. Yeah, reach is hopeless, I guess. What about Lasso? Yeah, Lasso takes some time. But we see that actually adding this feature in helped. So we reduced the error quite significantly. So now we can predict with with a lot more accuracy. So I'm just trying to play with different parameters and see which one works best. Because as I said, in my experiments, when I was doing this before recording the video, Lasso was better. I don't know what I did wrong. I think in my experiments, I actually filtered out all the this trip type. So I kept only dispatch. I think for dispatch it was better when I used Lasso, but for all the data it is better usually linear regression. That can happen, why not? And this one is probably taking forever. Yeah, because the data set is not super small. It's you remember it's 71,000. Oh, sorry, what is 74? Almost 74,000. It's not super small, right? So that's why for Lasso, I guess it takes some time. Yeah, but I think we can just go ahead and use this. I am going to stop it. It doesn't obey. Okay. Like while it is still running, I actually want to save this model. So I want to use this model later. So just add another cell here and import pickle. And now I will save the model. So with open, call it model bin. Maybe I actually need to create a folder. Let me create a folder. So we have folder data. I'll create a folder models. And with models, I'll call it linear regression. So the mode is WB, right binary. And I'll do pickle dump. And then we need to save two things. We need to save our dictionary vectorizer. And we need to save the model LR. And actually this LR, oh yeah, it finally reacted. So this LR will be this linear regression. So let me import this thing. So this is linear regression, and we save it to f out. Okay, so I just want to remove this. Yeah, maybe this will be better. I can't regret that I executed this. It will take forever. Okay. Yeah, so we will save our linear regression. Let me again do this as the best model we had so far. And this is the model that, let's say, we can deploy. So we will use this model or a variant of this model throughout the entire course. Maybe we will have like XGBoost model that is trained on similar, on the same data, but in principle it will be the same data, the same model, the model that is doing the same thing that we will use throughout the entire course. And yeah, so I think that's it for now for this video. So you saw how I approached training the model, and this is the data science approach. So I'm a data scientist. Usually I get a notebook and I start experimenting, I start importing, and then you probably saw me executing cells in a specific order. So for example, I wouldn't execute this cell, I would execute this cell first, and this cell first, and then I know that this cell takes forever, so I do not execute this. So you see, I cannot just take a notebook and execute the entire notebook and hope that it will arrive at the best model, because yeah, maybe like let's say if Lasso was the best model, while experimenting maybe I messed up, and when saving the notebook I accidentally left a parameter that is not the best one, right? So yeah, this is very experimenty notebook, like very, well, let's say, yeah, there are a lot of things I'm not proud of, but this is how data scientists typically work. And yeah, in the next video, I actually want to talk about some of the problems in this notebook, and then we will try to map these problems in this notebook to our course. So in our course, MLOps Zoomcamp. So each of the modules in the course addresses some of the problems in this notebook, and in the next video I will go through the notebook and map this to each module. So that's all for now. Thanks for your attention, and remember this video was optional, so if you just watched the end, that's also fine. Check the notebook in GitHub, and in the next video we will see how to map this notebook to the course content. So see you soon.